Alibaba Qwen has released their latest small vision language model. So this is Qwen3 VL4B. So it's a 4 billion parameters model, which means that it will require 8 GB of GPU memory, and you can have quantized versions of this particular model which can run in even lesser memory. Right, so Qwen3 VL is their most powerful vision language model in the Qwen series to date. So you have these bigger models in Qwen3 VL series. Now this is the smallest model, Qwen3 VL4B Thinking. This is the thinking version. There is also an instruct version of this particular model. Now this is a visual language model, which means that it can do tasks like OCR, it can do tasks like object detection, it can do long context and video understanding. It has native 256K context, right? It can do enhanced multi-model reasoning. It can do upgraded visual recognition, which is basically it can identify celebrities, anime products, landmarks, flora, fauna. This is a very powerful VLM, and this is a smaller version of that. So this is just 4 billion parameters. There is a Qwen3 VL 8 billion parameters also in this series, right? So let's try out this particular model using a Colab notebook. Before that, here are some performance benchmarks, and what they're saying is that this Qwen3 VL4B Thinking is quite competitive when you look at say a Gemini 2.5 flashlight on various benchmarks. Okay, that is what they are saying, right? If you look at all the benchmark scores over here, the 8B thinking model is much better than this 4 billion parameters model, right, on benchmarks. But in this video we are looking at this 4 billion parameter model because this can easily fit in 8 GB of RAM. Right, so let's try out this particular model in a Colab notebook. So I have actually already tried out some of the images, so I can show you the output over here. So this model took close to 9.4 GB of CPU RAM, right? So what you need to do over here is that you need to install the latest Hugging Face transformers. Okay, so you can do it like this. Then you need to install flash attention. Then you need to instantiate your model like this, right? So Qwen3 VL for conditional generation from pre-trained, and this is the model. Okay, and if you have flash attention to attention implementation, then it is much faster. Once you do this, your model is loaded. Okay, so this takes up to 9.4 GB of GPU RAM, right? So then you can create your processor and you can create your chat template like this, where you are giving an image as an input. For example, this is the image. Let's open this image and see what it is. So let me open it over here. Okay, it's downloading this image for some reason. Okay, so this is the image, right? So that is what you are giving the image URL over here, and the prompt is describe this image. Then you apply this chat template basically on this input on these messages, and then you push it to the GPU, and you do your you generate the outputs using model.generate by passing this input, and you print the output text. You actually decode the generated IDs, and then you print the output text. So it says that got it. Let's describe this image. First, the scene is a beach at sunset or sunrise. The sky is bright with a soft glow, probably from the sun. Low on the horizon, there is ocean in the background with the gentle waves rolling in. The sand is light colored, maybe pale beige, and you can see footprints of patterns in it. In the foreground, there is a woman sitting on the sand. She's wearing a plaid shirt, dark pants, and a white watch. It's actually giving the dog is a light colored Labrador retriever. It's giving a very good description for this input image. Okay, so this was the first thing which I tried out, and then what I did was that I wanted to give an infographic. Let's see, where is this infographic? Yeah, it is this infographic, right? And I was like, my question is like, describe this image. So this is a graph. If you see over here, there is a line, there is a graph, right? It says about Alphabet share price soared under Sundar Pichai. So I asked it, what is this particular image? It says that, it is a line chart about Alphabet's share price. Very good. The title says Alphabet share price soared under Sundar Pichai. Subtitle is saying about Sundar Pichai being appointed CEO in Google. Then there's a legend, red line for Alphabet, blue for S&P 500. The x-axis is years, y-axis is percentage points. Very good explanation. So the next question I asked is like, how much is the share price when compared to S&P 500 over the years? What is the difference? Basically 126 minus 59. So that's what I wanted. So the same image, I asked like, how much did Alphabet stock price increase when compared to S&P 500? Okay. So here it says that it does all these things. Let's look at the graph. The problem is asking how much Alphabet stock price increased compared to S&P 500. It finds the percentage points for both. So it says Alphabet is 126% label. Blue line is S&P 500 with 59% label. To the increase, what I need to is that I need to see the difference in their percentage points, right? It does all those things and it finally says that the difference is, Alphabet stock price increased by 67 percentage points more over S&P 500 over the period shown. Okay, so it has done the proper calculation over here, and 126 minus 59. It is able to interpret this graph, this labels, everything, and give the output. So this is just a 4 billion parameter model, and I'm quite amazed at this performance. The kind of improvement we are seeing in the vision language models is really huge. Okay, so then I gave this particular image of traffic, and I wanted to do some kind of an appropriate object counting over here, like the approximate number of vehicles in this particular image. So that is what I wanted to find out. I said, can you give me the rough estimate of vehicles on the road? So it says, let me try. First, I need to look at the images. The scene is busy with cars, buses, trucks, motorcycle. Let's start dividing the area into sections to make it manageable. The right side of the image has a sidewalk with pedestrians, but the main traffic is in the lanes. Let's consider the width of the road. It looks like a multi-road road and all those stuff. And what is the final answer? Let's look at it. Traffic jams, maybe 3-4 buses stand by alternatively. It's close to, for example, in New York, it is like this. Another way is this. Let's count the number. So it goes on doing something. Finally, what does it say? It says from the left, there is a vehicle, red bus, yellow truck, white car. Okay. Bottom part of the traffic is densest. So it kind of gives some kind of logic over here. Maybe it's run out of tokens over here before it can give a conclusion. So it is talking about this red bus, this traffic, some vehicles over here. Okay. So this was one image which I tried. Maybe more number of tokens can give better response. Then I gave this image of potholes. Where are potholes? Okay. Yeah. I gave this image of potholes and I said that's a road in Bengaluru. So I said, how many potholes are there on this stretch of road? Here it says that, what is the definition of a pothole? So first I need to identify what is considered a pothole. Potholes are usually deep, uneven depressions in the road, often filled with water. Let's look at the image, and then it finally says that, in this image, you have one pothole in the center, one on the bottom left, right? There are 4 potholes is what it says. There are 3 or 4 potholes, and it says which ones. Basically, one pothole on the bottom left, right? Bottom left, you have this pothole, you have this 1, 2, 3, 4. So it's able to do a good detection of that. Okay. So it says about a center a large pothole with water and a manhole cover. Let's see what it is. Oh, this one. Good. This is a manhole cover and a large pothole. Okay, so it is able to do pothole detection also very well. Then I gave it an image of Indian food. Where is Indian food? Here. Right, I gave this image and said estimate the nutritional profile of the food. So here it says it's done a good job here, I would say. So here it says that the user is asking, first I need to identify the items, and it starts identifying one by one over here. It says that we have rice over here. It's a South Asian thali with this thing, multiple curries, rice, flat bread. Let's list out each item. It says rice high in carbs, low in fiber. Typically cooked rice is about 25 grams carb per 100 gram, 1 gram protein, 0 gram fat. But since it's a serving maybe 100 to 150 gram weight, the image shows a generous portion. Then flat bread, roti or naan, whole wheat or refined. The image shows a brownish flat bread, possibly whole wheat, but maybe refined. Then it gives a kind of calories for that and the nutritional profile. Then the curry, it says it's a chicken curry, probably high. This is actually a vegetarian diet, vegetarian thali. It's not a chicken curry, so it is kind of, this is paneer basically. It kind of says that this is a chicken curry over here, right? Maybe it's okay. So probably that identification is not happened properly, but also fat from oil, and it gives yellow curry, maybe dal or lentil, perfect. Then you have vegetable curry, which is also perfect. Okay, it gives that this thing, raita, that's also there. Okay, so it kind of gives you the this thing total kind of how much calories. It kind of repeats the same thing if you see over here. Nutritional values of each item per serving, and then it kind of gives you the total, some kind of calories for each of them. Okay, so only the paneer curry, it couldn't do a proper identification in this particular image, but otherwise it's fine. Vegetables, this thing, everything, it has done a good job. Raita. Okay, so then I gave another image over here, which is this one, I believe. Okay, so this is a handwritten document, and I said, like, what is this document about? Just to see how it deciphers handwritten documents, kind of OCR. It actually does a good job over here as well. It looks at the document. The title is Rights in the Constitution chapter. Then it says a Bill of Rights prohibits the government from acting against rights and provides remedies. Also mentions Motilal Nehru Committee demanded a Bill of Rights in 1928. Then there is a section of South African this thing. So this Motilal Nehru Committee. So it has actually done a good job over here of interpretation of this handwritten document, right? So then what we have is that I just wanted to do that facial identification. So I gave this particular image and I asked, like, who are the people in this particular image? So it is actually saying these are leaders of Amazon, Apple, Google, Meta respectively, and it says each of these, Mark Zuckerberg. It talks about Tim Cook, Sundar Pichai, and everybody over here, Jeff Bezos and Tim Cook. It's able to identify all these things, and it also says that this looks at some Munich, somewhere there is this Munich, right? So maybe they were at a conference, but actually these are people from they could be at different locations, right? But it makes an assumption that they could be in a conference at Munich. That is what somewhere I have seen over here. Okay, so this is a very good visual language model for its size. Just 4 billion parameters, so which means that if you have a 8 GB graphics card or slightly more, you also have somebody says that now you have quantized versions of this particular GGUF models are there. Okay, there are tutorials to run it locally. So you can also run it on CPU, you can run it on lesser infrastructure as well. So this is a very good visual language model in my opinion. So you can also go and try out this particular visual language model for your tasks. Okay, and this is an Apache 2.0 licensed model, which means that you can use it for your commercial purposes. So you can think of this VLM for various visual language tasks. This is a small model, so you can try this model for your various tasks and see if it suits your purpose. So this is a small video on Qwen3 VL4B thinking. There is also an Instruct tuned version, so if you want to use, you can compare the performance to see which is better, whether you need thinking or instruction tuned is still fine. So you can go and check out these models. I'll be putting the link to the description of this particular model, the Hugging Face model link, as well as the Colab notebook, so you can go and try it out. Hope this video is useful. See you in another video.